Welcome to EDU World Space.
This is chapter 21, problem number 44. At what position x equals x maximum, the magnitude of the electric field along the axis of a ring is maximum. So since we're asked the electric field due to a ring of charge, let's go back to the example 21-9 and remember what the magnitude of the electric field was due to a ring of charge. It was qx over 4 pi epsilon naught x squared plus a squared to the power of 3 over 2. Remember this. Now, this is due to example 9. This gives us the magnitude of the electric field from a ring charge distribution. Now, in order to find the maximum of a function, as you know, we have to take the first derivative of that function with respect to the variable in the function and set it to equal to 0. And that's what exactly we're going to do here. So the e dx, let's put it there, qx 4 pi epsilon naught x squared plus a squared 3 over 2, right? Now let's take the constants out of the derivative because they're irrelevant. Q is constant, 4 pi epsilon naught is constant. The remaining stays in because they are a function of x squared plus a squared 3 over 2, right? We're going to have to take the partial derivative because we have x and a function of x in denominator. So let's start with the first x here. Q over 4 pi epsilon naught. Dx is 1, right? So 1 over x squared plus a squared 3 over 2 plus x times the dx of x squared plus a squared negative 3 over 2, right? I just flipped it so that I can show you the steps. Now on a new page, q over 4 pi epsilon naught. And here we have 1 over x squared plus a squared 3 over 2 plus x. And now we're going to take the derivative of this function here. So we have negative 3 over 2, and then we have x squared plus a squared. So we're going to do minus 1, right? Negative 5 over 2. And then we still have the x squared here, so we're going to have to take the derivative of that too, 2x. Now these 2's are going to cancel out, as you can see, but we have one more x here and x here, so we're going to have an x squared term. Let's not forget that. Q over 4 pi epsilon naught, 1 over x squared plus a squared, 3 over 2, minus 3x squared, 1 over x squared plus a squared, 5 over 2. Now, let's expand the first fraction by x squared plus a squared so that we can have the same denominator to do the subtraction here. Q over 4 pi epsilon naught x squared plus a squared minus 3x squared over x squared plus a squared 5 over 2. Now x squared minus 3x squared is a squared minus 2x squared, right, over x squared plus a squared 5 over 2. Now this equals to 0. The q over 4 pi epsilon is constant, right? Constant times this term equals 0, then this term has to be equal to 0. A squared minus 2x squared, this is a 2, my apologies, over x squared plus a squared 5 over 2 then equals 0. From here, then you can say a squared minus 2x squared equals 0. Then a squared equals 2x squared. Again, let's divide both sides by 2. X squared equals a squared over 2. If we take square root of both sides, then x is going to be plus or minus a over a squared over 2. Then let's take the a squared out of there. A over square root of 2 plus or minus is going to be where the electric field is maximum.